Hello students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the problems on gross calorific value and net calorific value of any fuel. So before going to that, we should understand what is the calorific value. So calorific value or the heating value of a solid or liquid fuel may be defined as amount of heat given out by complete combustion of 1 kg of fuel. So whenever we are combusting or burning, combustion of kg of fuel is done, the amount of heat that is liberated out of this is nothing but the calorific value of that particular fuel. So it is expressed in kilocalories per kg of fuel at normal temperature and pressure, and in SI units it is given in the form of joule per kg or kilojoule per kg or megajoule per kg. So how did we get to derive these units? Like calorific value is nothing but the heat given out per kg of any fuel. So heat is given in the form of kilojoules per kg. So therefore we have the units kilojoules per kg. So this is the unit we will be using in further problems. And in the calorific value, we have two types of calorific values. One is higher calorific value and lower calorific value. This is also called as gross calorific value, and this is called as net calorific value. So here GCV is nothing but the gross calorific value, GCV, and net calorific value is NCV. So here we will be calculating both GCV and NCV of any fuel. So what is the GCV or higher calorific value? So higher calorific value of a fuel or the gross calorific value is the total heat liberated by complete burning of 1 kg or 1 cubic meter of fuel. So if it is solid, 1 kg, and for the liquid it is 1 cubic meter of fuel, including the heat of steam formed by combustion of hydrogen in the fuel. So this gives the higher calorific value or the gross calorific value. So scientist Dulong has proposed a formula after several experiments, and he gave the formula like 33,800 of carbon plus 1,44,000 given into and hydrogen minus oxygen by 8. So this includes like carbon. So these are responsible for giving out the heat in particular fuel. So carbon, hydrogen, oxygen, and sulfur. So where does we get this oxygen from? From the air and sulfur. Okay, so H2 minus O2 by 8 plus 9270 into sulfur, and D given in the units kilojoule per kg. So this is the formula we will be using for the HCV or GCV gross calorific value calculations. Next, lower calorific value or net calorific value. So it is the heat liberated by complete burning of 1 kg or 1 cubic meter of fuel, deducting the heat of steam. So we are deducting the heat of steam, and so that will be the actual calorific value that is given for any fuel, and that is useful for the running machineries or automobiles. So that is formed by the combustion of hydrogen in the fuel. So we will be deducting the heat of steam. So if we want to deduct the heat of steam, we have to use this gross calorific value and deduct that from the gross calorific value, so that we get the lower calorific value or the net, what is the useful calorific value, that is the net calorific value. So therefore net calorific value is equal to gross calorific value minus 9H2 into 2466. So this formula is used to calculate the net calorific value and expressed in kilojoule per kg. So these are the two different types of calorific values present for any type of fuel. So these are the important formula, like this is the higher calorific value or gross calorific value, and net calorific value given in subtracting from the higher calorific value, mass of air required for complete combustion and mass of excess air supplied. So these are the different important formula that we will be using in these fuels. So first is the calculate the gross calorific value and net calorific value of a coal sample containing 84% carbon. So carbon is 84%, then 1.5% is the sulfur, and 0.6% is the nitrogen, and 5.5% is the hydrogen, and 8.4% is the oxygen. If you see here, nitrogen doesn't contribute to any calorific value, so we did not consider, and therefore we use remaining values and substitute in the Dulong's formula. So whenever we are substituting the percentages as such, we will be using this formula like 1 by 100 into 8080 carbon plus 34500 into hydrogen minus oxygen, this is oxygen, by 8 plus 2240 into sulfur. So this is the formula we will be using and expressing kilocalories per kg. So after that, substitute the values. 84 for the carbon, like here in the carbon place, like 8080 into 84 plus 34500 into 5.5, which is for the hydrogen, minus 8.4 oxygen, by 8 plus 2240 into 1.5 is for the sulfur. So after substitution and simplification, we get the value 8356.05 kilocalories per kg. So this is the gross calorific value. So it is including heat of steam. Because it is the gross calorific value, it also includes the heat of steam. So next net calorific value. So for net calorific value, we have to deduct the heat of steam. So we will be considering the GCV for this. Substitute the GCV, minus 0.09 hydrogen into 587. So the GCV value 8356.05 minus 0.09 into 5.5 is for the hydrogen. Substitute here into 587. So after subtraction, we get 8066 kilocalories per kg. So this is the net calorific value of that coal sample. So this is like in solid fuel we are using, so therefore giving in the form of kilocalories per kg. Next, a coal sample contains carbon is 75.5%, hydrogen is 11.25%, then oxygen is also 11.25%, nitrogen is 1%, and sulfur is 1%. Now calculate the gross and net calorific value. So again we will be using the Dulong's formula. So here also we are substituting the percentages as such. So 1 by 100. Whole by 100 or 1 by 100 is taken. So 8080 into percentage of carbon plus 34500. So 8080 into how much is the carbon? 75.5 plus 34500, and hydrogen is 11.25 minus oxygen is again 11.25 by 8 plus 2240 into sulfur is 1. As we know that nitrogen is not contributing anything to the calorific value. So we will be substituting this in the formula, Dulong's formula. And after simplification, we get 9518.893 calories per gram. So this is like we are reporting in calories, so therefore giving in grams. If it is kilocalories per kg. Next, net calorific value. So similarly, GCV minus 584 into like hydrogen by 8. So we will be substituting the hydrogen value here. So GCV value is 9518.893 minus 584 into hydrogen by 8. After simplification, we get 8693.425 calories per gram. So this is the value for net calorific value. So this is the actual calorific value that the sample contains and useful calorific value for that particular fuel. Next, calculate the net calorific value of a fuel if its ultimate analysis comes out to be containing carbon is 64%, oxygen is 14.56%, hydrogen is 10.44%, nitrogen is 6.52%, sulfur is 4.48%. So this is not required because it is not contributing to the calorific value. So now we will be using the Dulong's formula again and divided by 100 because we are substituting the percentages as such, and we substitute the carbon and hydrogen values, oxygen values and sulfur value here in percentages. After simplification, we get 8,245.452 calories per gram. So this is the GCV value. Now NCV, the net calorific value, is equal to GCV minus 0.09% into hydrogen into 587. So this is the net calorific value formula. So now we will be substituting the gross calorific value minus 0.09 into percentage of hydrogen 10.44 and into 587. This is because the latent heat of steam. We are multiplying with latent heat of steam. And after simplification, we get 7,693.907 calorie per gram. So this is the net calorific value of that particular coal sample or the fuel. So here if you see, always the gross calorific value is higher than net calorific value because we are subtracting that latent heat or the heat of steam. So therefore, this will be always lower. The net calorific value or lower calorific value is lower compared to gross calorific value or higher calorific value. So whenever we calculate the net or gross calorific values, we have to remember that the value of the net will be lower than the gross calorific value. Next, a sample of coal has the composition carbon is 70.3%, hydrogen is 5% like 5.1%, oxygen is 22.4%, nitrogen is 0.4%, and sulfur is 1.8%. Even though nitrogen is given, it is not contributing, so we will not be using in the formula. And in the Dulong's formula, 1 by 100 is equal to 8080 carbon plus 34500 hydrogen minus oxygen by 8 plus 2240 sulfur in calories per gram. So it is nothing but 0.01, and 8080 into 70.3 for the carbon. Hydrogen is 5.1, so 34500 into 5.1 minus 22.4 by 8. So after substitution and calculation, we get GCV value is equal to 6513.3 calorie per gram. So this is the GCV or the higher calorific value of that particular coal sample. Next, net calorific value. Substitute the GCV value in this net calorific value, and 9 is the value that we are taking, 0.09 or 9 into 5.1 by 100 into 2260. So after some simplification, we get 5475.7 calorie per gram. So this is the net calorific value, and we report in the kilocalories per kg or calorie per gram for the same. So this is how we will be calculating the gross calorific value and net calorific value for the whole sample when the composition is given in the percentage. So even if the nitrogen is given, nitrogen is not contributing to any of these calorific values. So therefore, we will not be considering nitrogen or oxygen content. Air, if it is given also, we will not be considering in these calculations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.